Simpson Math here with our last Algebra Highlights video. I hope you have a great summer after today. Well, I hope you've been having a great summer studying algebra with me, but I hope you have a relaxed rest of the summer. In this short video, we're just going to introduce the topic of logarithms, which is something you should see in Algebra 2, and we're going to for sure see in the fall when we do our STEM algebra class. Okay, here we go. So I have the definition here, but I'll move over here and write it again and talk about it. So we have an exponential expression here. We call this number the base. This number is the exponent. And then we call this number the power. So for example, 8 is the third power of 2. Okay, and we've been doing some exponents in the last few lessons, so you're kind of familiar with that. Now, something I need to point out over here, the base is always positive. It's never a negative number, and the base doesn't equal 1, because 1 to a power is still 1, and that would just be boring. So the base is not 1. It can be a fraction like 2/3 or 4/5, or a small fraction like 1/1,000,000th. And it can be any number bigger than 1, like 10 or pi. Okay? Now, this implies that the power will be positive. Because if your base is a positive number, there's no way to raise a positive number to a real number exponent and get a negative. Like you might think, what about if I raise it to a negative? But remember, a negative just means that it's equal to the reciprocal. A negative exponent just means the base is equal to a reciprocal, and the reciprocal is still going to be positive. So when we say the base is positive, that means that the power will also be positive. And that's not usually stated in the definitions because it's implied, but I think it's important to point out. Okay, so we're ready for the definition of a logarithm now. So when this is true if and only if log base b, so we still call this the base, b is still called the base, but now p is the input of the log or the argument. So now we call the power the argument or input of the log. And then the output of the log or value of the log is the exponent. So you put in the power into the logarithm and you get out what the exponent would be on this base to give you that power. That's the definition. And there's the definition of a logarithm. Let's do a couple of examples to make you a little more familiar. So if we have 2 to the third is equal to 8, logarithmically, that's log base 2 of 8. What exponent do you put on 2 to get this 8 as your power? That would be 3. Now, the simplest case is when we're talking about nice rational numbers. I have a whole number exponent, so I get a whole number power, and I had a nice rational base. Let's do another one of those. Here we have 10 to the negative 2 would be, remember you flip the 10 to 1/10 and then you square it, so that gives you 1/100th, and you can write 1/100th as a decimal. Let's pull that over so we can see it all. So we would write log base 10 of this power would be, what exponent do you put on 10 to get this power? Well, it would be negative 2. Now, something to note, we don't write the 10. So this is called the common log, and the most common notation for the common log, base 10, is just to write log without the 10. So if you don't see a 10 here, it's probably, I mean, if you don't see a number for the base, you should read the fine print of the text, but you're probably talking about log base 10. I have seen books where they use this notation to talk about something called the natural log, which I'm going to mention here in a second. So you have to read the fine print, but usually when you don't see a base, the base is understood to be 10. Okay? Now, the natural log. E is an irrational number that's sort of like pi, one of those special numbers that comes out in mathematics. In calculus, we'll deal with the definition of E when we get to limits and that sort of thing, and series. But E is approximately 2.718. It's an irrational number, so this is rounded off. I can't write it in decimal form because it's irrational. It goes on forever without a pattern or without terminating. But that's what it's approximately equal to, or you just, if you're doing rough calculations, 2.7. Now, if I have e to the negative 1, the power would be 1 over e, which is approximately 0.35. I did that in my head, so the calculator may spit out a slightly different number. But we would write log base e of this power, 1 over e. What exponent do you put on e to get 1 over e? That would be negative 1. However, books tend to not write the e, sort of like we don't on the 10. And like I said before, some books use just this notation, the log, to refer to what's called the natural log. This is called the natural log. And you learn why that terminology comes out in calculus. But this is called the natural log. Some books use this notation, but most don't. Most use ln. And since the TypeScript that I type in uses just the L that looks like that, it looks like a 1, I'll frequently write ln like so, in capitals. But this is more common to write lowercase ln for natural log, and that just means log base e. One different thing we could talk about is not all powers are nice rational powers. So we know that, of course, you can raise 2 to a fractional power, and that gives you the square root of 2, which is an irrational number. So the logarithmic expression here would be log base 2 of the square root of 2. What exponent do you put on this base in order to get this irrational power square root of 2? Well, it would be the fractional power 1/2. Now, one goal you want to have is to be able to evaluate a logarithm. So if I put log base 6 of 36, you want to be able to evaluate the logarithm. That means you're looking for the exponent. The exponent is x, the base is 6, and you want to know what exponent would give me 36. Well, that's clearly 2. 6 to the second power is 36. So this would be 2. So that would be how you would evaluate a logarithm. Math made simple, Simpson Math.